Hello everyone, let's do LeetCode hard question 884, largest rectangle in histogram. This question is asking you, if you were given a list of heights, how to find the largest rectangle that can be formed in these heights. On the first side, you may think maybe brute force will work. So you can try out brute force and you will realize that will exceed the time. So if that exceeds the time, that means there will be a shorter way. And by shorter way, it means it will be able to avoid some repetition. Then the next question is, where are these repetitions come from? So repetition. So if you really think how each rectangle is formed, you will realize there are many bars in the rectangle, and when you use the brute force, each bar is used to calculate you calculated the area of the rectangle at each bar, and that's where the repetition comes. So then how to avoid it? Before, for brute force, you are using a mapping like one rectangle is mapping to list a group of bars. So one way to avoid this repetition is if you can find a criteria that can make why one rectangle maps to a single bar. Then the next question is, what should be the criteria to select a single bar inside this rectangle to represent this rectangle? And this is the key to this solution. This representative bar should be the lowest bar inside this current rectangle. The reason being, if you think how rectangle is formed, it is literally decided by the lowest one. There can be many bars higher than the lowest one. But if you do the reverse, if you don't think that's intuitive, you can try to think the reverse. If you want to use the highest bar as a representative bar, then you will realize that the other bars will just not be included when you really want to see this rectangle. So if you focus on the first bar, all other bars will be filtered out. Instead, if you focus on the lowest bar, all other bars will be included. So that's the logic why you have to choose the lowest bar. So the answer for this one is lowest bar. I cannot spell today. Okay, so the logic is very clear. We want to find the lowest bar for each rectangle. And now, do we have a tool to let us find this one-to-one mapping? And the answer is monotonic stack. So before I explain this monotonic stack, another thing I want to address is if we use the lowest bar in each rectangle to represent this rectangle, you may feel confused. What if this rectangle has multiple lowest bar? And that will be addressed by this structure as well. If there are multiple lowest bar in this rectangle, only the left one will have the maximum area. So yes, it will still be calculated repetitively, but they are not targeting the same rectangle. And to the worst, there will generally be more uneven rectangle than like all the bars same, so it will be better. Clearly, we know we need a stack and we need something to return the value, which is area of the rectangle. So these two values one is least, one is, of course, you start with 0. And one thing about this monotonic stack, how it works, it's keep reading in heights that higher than all the heights inside this stack. So in another video, I explain how monotonic stack work. Basically, it is maintaining this monotonically increasing stack, which means when you iterate this list of heights from left to right, when the new height is higher than any of the height inside this stack, it will keep popping the last height from the stack until the current one is higher than the last one in the stack. By doing this, you can repeat it in your mind several times. By doing this, it is guaranteed that all the values in the stack will be monotonically increasing, because all the lower ones are popped out, so only the higher one get to enter it. And because of that, at the end, it's possible that our values in the stack are not all popped out, because you can't guarantee you get a list of heights where the last height is the lowest. And because that's the only mechanism we have to pop out value from the stack, we need a way to force all the values to get popped out in the end. So because of that, we want to artificially add a 0 height at the end of the given heights. By adding this 0, because 0 is lower than any of the heights, it is guaranteed all the values in the stack will be popped out. And also because of this one, we want to add a -1 so that when we calculate the distance, which I will show you later, will be easier. And second, it can save us a step of checking if this stack is empty. Because when the stack is, let me add here, each element in the stack, you can add a tuple, but I will just add an index that is enough to track all the heights and the index, of course. So when you add a -1 here, that is actually pointing to the last one in the heights, which will be 0 and which will be lower than any of them, which means it will never be popped out. And that means we never need to check if the stack is empty before popping, because the stack will never be empty. Okay, so when the new value, which is the height, is smaller than the current last height in your stack, which is, remember, in the stack it is index is not height itself, so we need to do this. If it's smaller than the last one, then we need to keep popping it. And remember, when you pop it, this is just the index, and what you care is the height. This is the lowest bar in your rectangle, which means you got the height. Then the next is you only need to multiply the width. So what is the width? The width is this new index minus, after the stack popped out, minus the last one. But this gives you the distance between the rectangle that represented by this height. Basically, I'm saying if this height is the lowest bar in this rectangle, then this is the width of this rectangle, which also means this is the distance between the very first left bar that is lower than this lowest bar, and the very first right bar that is lower than this lowest bar. And why this -1 is, if you just pull out your left hand and count, if your pinky is the very first bar that's lower than your lowest bar, and your thumb is the very first bar that is lower than your lowest bar in the current rectangle, then the distance should be 3. But when you use your thumb, which should be 5 or 4 here, minus your pinky, which should be 0, then you get 4. And that is 1 bigger than the number you're supposed to get, which is 3. So that's the reason you should minus this extra 1 here. So this is the current area you get. Now you can update this area. And after you popped out all the height that's lower than the current, then it's safe to add the current index. Remember, the element in the stack is the index, not the height. Add this index. And that is all for this question. You can return the area. Oh, sorry. So that's all. So that's all. I really like this solution. This is the type of question that the problem sounds so complicated, but when you write the solution, it's so elegant that you have to really understand what's going on to reproduce this solution. It's really nice.